All right, next tab we're going to move into is our transformation piece, where we're going to take some functions and we're going to do some transformations. So that being, what we're going to do is we're going to take a graph, slide it around on the coordinate plane, maybe reflect it. You know, a lot of you will talk about is flipping it, you know, stretch it, shrink it, and things like that. So number one, what we first got to do is deal with our parent function. So most of this is just going to be, I'm going to go through quickly. It's going to be something that we'll use as we go through and do some of these transformations along the way. So when we talk about a parent functions, I'm taking some function where I haven't done anything to it other than what this function's asked me to do it. So in this case, y equals x squared. All I've done to my x is squared it. I haven't added anything, I haven't subtracted, I haven't multiplied it, nothing. This is our quadratic function again. And a few things that we're going to look at in terms of our functions is, one, we're going to look at a table of values that's going to allow us to graph these a little easier. So what we do is we just start out with picking some x values, just like you did way back when you first started looking at graphing things. And so when I plug -2 in and square it, I get 4. Plug in -1, I square it, I get 1. 0, 1, 4, same thing. And so we get our graph, which most of us probably expected to be that parabola again, because we've seen those before. Okay. And again, remember, it's U-shaped. We'll get to the absolute value again, which is V-shaped. It's not connecting the dots. Now, one thing that we're going to add in here is we're going to talk about our domain and ranges. Okay, domain again, my x values. What x values can I plug into this function? I can take any value that I know in terms of real numbers and square it. Okay? And in terms of looking at that, a lot of times what I'll tell people is if I go in and I take my pencil and I slide it along and I think about, is there a point on that line that hits with every x? Yeah, this keeps going up and up and up and up and up. And then I'm going to do the same thing with my range, which is my y values. Okay. A little differently with our y values here is that, yeah, I have a point on my line here, I have a point on my line here, 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 but I don't have anything down on this end. And that's because when we square something, we always get those non-negative numbers. We get positives, and but 0 squared is 0, so we talk about as non-negatives. Okay, we're going to use those as we transform our functions too, because when we move this graph around, it's going to be in some different places. All right, so x cubed. This is going to be our cubic function. Okay, again, I haven't done anything to my function except raise it to the third power. Okay, so again, if I take -2 times -2 times -2, I get a -8. Okay, and so this is my table that I get. It's not going to quite fit, but we're going to go there. And what it kind of looks like is if I drew this part right here, it looks like my parabola still, but then it looks like on this side that I took the parabola and flipped it over the axes. Okay, so now what's going to happen for my range and domain here is my domain, I can plug any value in for x and I truly will be able to get any y value out. All right. Next one, square root function. Now a little different table here because of the fact we don't want to deal with decimals. Yeah, I could take the square root of 2 and get a decimal value. But what we're looking at is if I take the square root of 0, I get 0. Square root of 1, I get 1. So on and so forth. What we really did is we started with these numbers and kind of went backwards. Okay, what would I get for for x, I'm sorry, if I squared the y values? Okay, so if I plot my points again, okay, I'm not going to fit those other ones in, but again, I kind of get that parabola shape, but it's only half of it this time. Part of that being, again, because we're talking about when we graph only using real numbers. We don't know how to graph imaginary numbers, okay? So the only x values I can use are x's that are greater than or equal to 0. Because again, if I take the square root of a negative, it becomes imaginary. I don't know how to graph those, okay? My range, because of that, my y values are also going to be greater than or equal to 0. All right, cube root. Okay, cube root. Now, you're just going to go backwards, and if you actually go look at the table of values for y equals x cubed, it's just x's and y's switched around. And that's what's truly happening. They're called inverses of each other. Okay, my domain and range are going to again be the same. And here's one of the reasons why I always ask people to use 5 points, because if I just go with the 3 points, okay, people see that cubed and they think, oh, that's this one again, which it isn't. Okay. That's why we want to go with the other 2 points out here as well and kind of see that it looks like x cubed, but laying down. Okay. All right, and our last one, absolute value again. Absolute value, as you recall, is your distance from 0. And that's why we talk about as non-negative. Okay. -2 is 2 units from 0. -1 is 1 unit from 0. And here's where we get the V-shaped one. So this is the one that's a little different than the others. Okay. Now my domain, everything's got a distance from 0. When we talk about real numbers, my range though, because again, our non-negatives, it's always going to be greater than or equal to 0. All right. Now, what we're going to do is we're going to take this general function and we're going to make some transformations to it to help us graph some of these functions a little easier. Now, don't worry about the f piece, okay, because what that f piece is talking about, it's which function. Okay, when we're saying which function, is it x squared? Is it the square root of x? Is it x cubed? Okay, so on and so forth. But notice there's a couple of things that we can do here. Okay, on the inside, that's my x stuff. Okay, and what you see we can be doing is we can add or subtract something to it, that being the c, or we can multiply by b. Okay. On the outside, that's going to be y stuff. And what I could do is I could manipulate this equation by subtracting my d over to my y and then dividing my a away from both sides and get them to be on the same side with it. But what we're going to look at more is inside and outside stuff. Okay, and when we talk about inside, we're talking about inside parentheses. We're talking about inside an absolute value. We're talking about inside a square root or a cube root. Okay. Inside that. When we get to exponential functions, we'll talk about inside the exponent. When we talk about rational functions, we'll talk inside my denominator. Okay. So I'm going to start with the outside stuff first, okay, because that's pretty simple. And the easiest one's your d. What d is going to do is move your graph up and down. Okay. So for instance, when I get to this situation, when I see this 3 on the outside, okay, what that's going to tell me is happening is that I'm going to move my graph up 3. Sorry, up 3. Okay, and we'll get to how that process is going to go here in a little bit. Okay. The a can have 3 effects on our graph, and we're going to get into that more in the next presentation. But 3 things that can happen. A could be negative, okay? And if it's negative, what we're going to say is happening is we're going to reflect it over the x-axis. We're going to flip it. That's what a lot of people say, but it's true mathematical terms. We're going to reflect it over the x-axis. Okay, and we'll go in more detail with that later. Now, this says absolute value of a. What we're saying is once I've looked at my sign, now all I want to look at is just the number part. The number part's bigger than 1. Now, when we talk about y, that's up or down, that's vertical. We're going to call that a vertical stretch. Okay, and I use the example of taking one of those exercise rubber bands, and if I put my foot on it and I pull up on it, I stretch it out. What happens is my graph, and an easy one to kind of use as an example is x squared, it's going to get more narrow. Okay? When it's somewhere between 0 and 1, because again, we took care of the negatives already, this is going to be what we call a vertical shrink. This is when I let that rubber band go and it gets wider as it gets closer to the ground. Okay, so those are the easier ones, I think, because they make sense. Okay, they make sense that, hey, if something gets, if I multiply it by a number bigger, it's going to get larger. Okay, it's going to get pulled away. Now, the inside is where we run into some issues once in a while. But one of the big things to remember about inside is what we're going to do is the opposite all the time. Okay, we're doing the opposite of what we think. So I'm going to start with that C value again. Okay, what that's going to do is move me left or right. Okay, kind of like the D moved me up or down, but now we're going to go left or right. Now the tricky part here is I'm going to move to the left when C is positive. I'm going to move to the right when C is negative. Okay, so when I look at this one, I'm looking at that -2. Okay, I'm thinking negative moves me left, or -2 is to the left, but what I'm actually going to do is go to the right 3. Okay, so it does the opposite. Okay, so that's one thing that people goof up once in a while, but we got to be careful with that. Okay, B is going to also do 3 things just like A did. Okay. When it's negative, it's going to reflect again, but it's the opposite axis. So instead of the x-axis, it's now the y-axis. Okay. Number part again, when we're talking about absolute value of B, when it's greater than 1, opposite. So not vertical, it's horizontal. And a horizontal, again, that's left and right. And it's not stretch, it's going to be a shrink. Same way, when it's between 0 and 1, it's not vertical, it's horizontal, it's not a shrink, it's a stretch. And like I said, we'll get into those more in the next presentation. All right, so going back to this one, we've taken care of describing what's happened, okay? I have that -2, I have that +3, well, I wrote a minus, or 2, 3 there, it should be a 2. Okay, here's how we're gonna do the whole process, okay? Number one, we start out with a parent graph. When you think about the parent graph, think about it as if we took the plus and minus stuff away. What's left? Y equals x squared. Okay, what I'm going to do then is from my parent graph, I'm going to fill in my table. I'm going to fill in my domain and range. Now, how I'm going to transform it is to go in and look at my transformations. I went up 3. Up 3, that changes my y value. Okay. So what I'm going to do is I'm going to move every one of my y values up 3, which means I'm going to add 3 to each one of these. And then I do the same thing to my range. Okay. So now my y's are going to be greater than or equal to 3. My x's are to the right 2. Okay. Now, again, opposite. Rather than subtracting 2, what I'm going to do is add 2 to each of these. Okay. Now, I always suggest to people, once you've changed a set of x's or y's, to cross them off. And now replot your points. So if I go 0, 7, 1, 4, 2, 3, 3, 4, 4, 7. If we have 5 points, we have a better chance of making sure that we have the right shape. And as you can kind of see, I did go up 3. 1, 2, 3. I did go right 2 if I just look at my vertex. If I look at my domain and range, okay, well, I kind of forgot to talk about this, but I should have subtracted 2 from my domain as well, but when I do anything to reals, this is all going to be all reals. Okay. All right. Good luck with that.